And I don't even have that now. And that happened after I came in and after I went out and came back in. So I don't know what the deal is. I don't share a camera, I share my computer screen. The biggest problem is I can't communicate with them to figure out what's going on because I can't hear them talking to me.
Is this a 6-week process?
I know, I think.
Paris looks like that. Oh, is that you bringing Paris back on? Something I just saw a green check and
And that's
that's what
here.
I'm sharing with them. It's the purple one is our purple one, the one next to it. The one on the right there, the tab on the right. And the Sulphur Springs is showing muted now, but they're unmuted. Don't have a student in there yet, so can't really do anything there.
And you're on, right?
I think I am when I asked, there were some.
Well, we're not getting a signal.
Oh, maybe my, well, they were saying that the people in Paris, there were 3 of them there, and I think they were signaling me that they could hear me and they could see my document camera, but I couldn't hear them. And I thought my microphone actually came through my document camera.
Degree.
'Cause I don't use that camera.
4-year code. I just need to do this class so I can.
And like I said, I don't think the problem is me hearing me. I think the problem is me hearing me.
Yes, ma'am.
Okay. Paris can hear me, I can hear them, we can hear everybody else. It's just Mr. Norris who isn't hearing us.
Yeah.
Okay, so maybe check the setup for the audio. You know how to do that?
I'm sitting here now.
Okay. You see down in the bottom right where that, I think it's kind of a purplish colored
Yeah.
bullet with some arrows. If you click on that,
It says 4.
okay, and then
Right.
click on the little gear, that's for settings.
Click the my settings. All right.
All right, and then where it says audio and video settings,
Yep.
all right, set up your camera and microphone.
Has he?
I haven't done it yet.
You've done anything?
No, it's due in like October.
I just practice. You didn't do anything great. How if you're looking at great everything this summer?
All right. The microphone. Speaker volume's at 100%.
Okay.
Now I'm looking at somebody. Who is that Sulphur Springs? Is that y'all?
Yes,
Yosha is on her, that's Silver Springs.
Okay. Yeah. It was X'd, right. Okay, well, how do we unmute it? That's what I saw. I thought this was. Can you hear? All right. I did something. Wi-Fi, no, none of that stuff, do it. I don't need that, do I? Well, I can't get the X off. And the speaker at the bottom. It says not connected. Bluetooth, this is Bluetooth, well,
You just click that and turn that unmute it. Just click that. I don't know.
no, it doesn't. It's got an airplane mode available. PC, new, student.
Does the speaker need to be unmuted? Well, that's got the X there.
It's not coming up with a box, and I'm looking at the very bottom next to the date and next to the time, correct? And it's got the picture of the speaker with an X beside it.
Put it back up there. Put that speaker back up.
On your keyboard, is there like an FN?
Okay.
mute
Let me
button?
see it real quick.
Okay, wait a minute, he's gonna try something here.
Just unmute
That's
it.
probably did it there.
Well, that unmuted it, but,
That unmuted the speaker.
Well, like I say, it's me not hearing them that I think is the problem, not them not hearing me. Maybe it is, I don't know if they're or not.
Anybody? The Sulphur Springs?
Celeste, can you hear me? Wave at me if you can hear me.
We can
Wave
hear
if
you.
you-
No, it works now.
Okay,
Fix it.
and you can see, could you see my document camera when it was up? I know he's probably turned it off now.
Yes.
Okay, so the only problem then is that I cannot hear you guys. So the only issue would be if y'all have a question I need to answer, I won't know. If you could actually go to the keyboard and type a question in the chat box. If you click on the chat thing, but the other thing is I can't see Paris's camera. It shows that they're on, but I don't see them. So I did earlier, and they said they could hear me, but I couldn't hear them. But now I cannot, I don't know if Paris is on and they can hear and see me and their camera's just been lost, or if I've totally lost the Paris campus. I don't know which it is.
Have you got Paris? Can you hear Paris?
I'm not seeing anything.
Yeah, I'm hearing something. We're hearing something now coming
Let me put my
through.
document camera on. They can see it.
I don't use video. I use a document camera.
They're coming through now.
Okay, great. Thank you.
Oh, yeah, I got them.
Okay, I'm gonna hang up.
Okay, now can y'all see my document camera now?
Yes.
Okay, good. We're good then. It's just now, have we lost Paris? That's the big question.
Miosha,
Hello?
is that
Can you hear
Paris?
me?
Can y'all hear,
Oh,
can
yeah.
y'all hear us?
Yeah, I can hear you. Is that Paris?
Yes, yes it is.
Okay, and y'all are seeing the document camera and hearing me.
Yes.
Okay, I think we're back. I don't know what was up with the audio, but we're back. It's probably up too loud now. I had turned it up. That's cool.
You think that's all right now?
Yeah, I think so. I can usually tell when I get too loud because I can hear myself echoing back through their speaker. All right, y'all, it seems like it's up and running and y'all can hear me. So, wow, what a nightmare that was.
And I still don't know if we don't know what was wrong with the audio, right? Like, did we know what we did that got the audio working? Yeah, okay, so you think I did it? Okay, we're going with that. It's working, we're gonna go with it. Thank you. All right, y'all. It's the Napoleon Dynamite song. Yes, I love technology, but not as much as you see. Okay, we seem to all be here now going. I can actually see Sulphur Springs. Mioshe, I'm assuming you can hear me. I haven't heard you. Okay, good. So I'm hearing everybody. I can't see Paris, which is fine. I mean, I don't have to see you as long as you can see me. So that was an adventure. Okay, seems like we're up and running now. So, all right, so here's kind of where we're at. We're going to start tonight with the quadratic formula, which is the back end of section 1.5. We're going to look at the formula, look at how we use it. We're going to work through a couple of examples where we're going to solve equations using this formula. Then we're going to cover section 1.6. And that'll be it for tonight. I did not get y'all's practice tests sent out in time for them to give them to you tonight. In Greenville, I don't ever hand stuff out here until they also get it on the other campuses. But let me say this about that practice test. I believe it just says practice test 1 or practice for test 1. You will find it on our course page. There is a link to the first practice test on our course page. I would urge you this week to click on that link, and if you got a printer, you can print it out. It's a PDF file. If you don't have, you can just download and print it out. If you don't have a printer, you can at least look at it on your computer, and I would encourage you to try to work through as much of that as you can this week. By the end of the night tonight, we will be, let me show y'all what that thing looks like, because there is one thing I need to show you. I'm going to stop sharing my document camera. And I'm going to try to just hang with me a second. I'm going to find that practice test. I'm going to try to share that with you. Let me see. Okay, that's there. So let me see if I can share that. Okay, so this is it. I can probably blow it up some too. If you click the little dots up here, you can actually download it to your computer where you could print it out. But I'm just going to blow it up and show it to you. So make it a little bigger. So that's probably big enough for you to see it. Okay, so this is our practice test. It's right there linked on our course page. You can see these are problems from 1.2, and then we get to these complex number problems from 1.4. And then you can see these are quadratic equations that these first couple you could solve by factoring. That one, number 11 there, you'll need to use that square root method. We went through all of that last week. 12 and 13 are using the quadratic formula. That's the first thing we're going to look at tonight. 14 through 17 all come from section 1.6. That's what we're going to cover in the second part of class tonight. And then 18 through 21, these come from section 1.7, which will be covered in the first part of class next week. Problems, so y'all make a note of this for when you look at that thing. Problems 18 and 19, for sure, there will be problems like that on the first test. 20 and 21, those are called absolute value inequalities. We may not get to that next week before we take our break and come back and go over this practice test. So I'll just go ahead and say now, and this way you don't have to have any questions about it. The stuff on the practice test after problem 19, you won't have to worry about for the test. because I don't think we're going to get anything. This stuff down here is from chapter 2. We won't get that anyway. That'll be on the next test. 20 and 21 will not be on the test. So it'll be problems 1 through 18 that you need to worry about. And by the end of class tonight, we will have covered all the material through the first 17 of those. So the only material we won't have covered by the end of class tonight that will actually be on the test are problems 18 and 19, and that's what we'll look at in the first part of class next week. So at any rate, if you get a chance to look at that practice test this week, I would encourage you to do it, because what's going to happen next week is in the first part of class, we're going to cover as much as we can of section 1.7. Then we're going to take our break and we're going to come back and we're going to work through this practice test, through those first 19 problems that are similar to test problems. And what my experience tells me is if you haven't looked at any of those problems and tried to work them yourself, and then you come in next week and just watch me do the problems on the whiteboard, you'll leave class next week having convinced yourself that you're ready for the test. Because, you know, it's a lot easier to watch somebody else do math than it is to actually do it yourself, right? So try your best to find a little time this week to look at that practice test. Try to work through as much of it as you can before we come in next week. But anyway, next week, we'll cover what we can of 1.7. Then we're going to take our break and we'll come back and we're going to work through those first 19 problems on that practice test. Then the following week, so not next Wednesday, but the following Wednesday, that's going to be our first test. You will see that the test is very, very similar to the practice test, okay? So that's kind of where we're at, just trying to get through this first chapter and get this first test taken. Okay, I'm going to go back to our document camera, so let me get out of that. Let me see if I can share our document camera, and we're going to get rolling here. Okay, so make sure I'm kind of focused as this thing will get. Okay, so this is our quadratic formula. And I know, I told my Monday class, this looks like kind of math gobbledygook, but notice it says if ax squared plus bx plus c equals 0, ax squared plus bx plus c equals 0. In other words, if you have one of those equations that involves a quadratic trinomial where it's some number times x to the second power plus a number times x plus a constant term equals 0, then this little formula will give you the solutions to that equation every single time. And what it says, you know, if you read this off, I know it looks complicated. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it looks complicated, but all it's telling you is whatever this number b is, the number that's multiplied times your first degree x term, you just plug that number into this formula here and here. And a, whatever the number is in front of the x squared. Of course, if there's not a number in front of x squared, a would be 1, right? But whatever number a is, you plug it into the formula here and here. C, whatever your constant term is, you plug it into the formula here. Once you plug that in, then you would just need to do the arithmetic to simplify this to find the solutions to the equation. So we'll see how the formula works. We're going to work through a couple of examples here so you can see how you use the formula. So the reason we need this formula is because last week we looked at a bunch of these quadratic trinomial equations where this quadratic trinomial, you could factor it. And we know if you can factor it, you just figure out what makes each factor equal to 0, and that gives you the solution to the equation. But what if it can't be factored? And this is one that can't be factored. If you tried to factor this, you could try and try. You could try everything you would think of. Nothing would work. You couldn't come up with a way to factor it where you get something that if you FOIL it out gives you this back. So obviously, if it can't be factored, then solving this equation by factoring isn't an option. So that's when we need to use the quadratic formula. So Notice ax squared. A is the number that's multiplied times x squared. So our value of a is 3. B is just whatever number gets multiplied times x. Well, notice here that number is not 2, but negative 2, right? If that had been plus 2x, then B would be 2, but it's minus 2x. So our value of B is negative 2. It's just whatever that number is that's multiplied times our first degree variable x. And then C is our constant term. And again, notice C isn't 3, C is negative 3. Everybody with me there? So all we're doing at first is we're just figuring out what are our particular values of A, B, and C for this particular problem. Now we're going to plug those numbers into the quadratic formula exactly where it tells us to. So x equals negative b. Well, that's going to be the negative of negative 2. So whatever number b is, you put it right here, but you put a negative in front of it. If that had been positive, if b had been positive 2, of course, we'd have negative 2, minus 2 here. But it's minus negative 2 plus or minus the square root of b squared. Well, that's negative 2 squared. Make sure you see that no matter what number b is, if this was negative 2 or positive 2, it wouldn't matter. When I square that, I'm going to get positive 4. Does everybody see that? Sometimes I'll see students where if b is a negative number, like negative 2, they'll square it and they'll say that's negative 4. But remember, if you're squaring a number, you're multiplying it times itself. So it doesn't matter if b is positive or negative. When you square it, you're going to get a positive, right? But it is negative 2 squared, b squared, minus 4 times a. Well, our value of a is 3, times c, right? And our value of c is negative 3. So there's the square root of b squared minus 4 times a times c part, and that's all over 2 times a, and our value of a is 3, so that's all over 2 times 3. Everybody see that? All I've done at this point is I've plugged our values of a, b, and c into this quadratic formula exactly where the formula tells me to, right? Everything else now is arithmetic. We just got to do the arithmetic to simplify these numbers. And I say these numbers because there are going to be 2 answers here, right? There's going to be this plus that stuff over 2 times 3, and also this thing minus that stuff over 2 times 3. So there's going to be 2 answers. At any rate, now I'm simplifying. So the negative of negative 2 is just positive 2 plus or minus the square root of negative 2 squared is negative 2 times negative 2. That's positive 4. This minus 4ac part, be real careful. You got to watch your signs. We could do negative 4 times positive 3, which is negative 12. And then negative 12 times negative 3 is positive 36. Everybody see? You got to watch your signs there. And that's all over 2 times 3, which of course is 6. And so now what we've got then is 2 plus or minus the square root of 40, right? 4 plus 36, 40. So 2 plus or minus the square root of 40 all over 6. Now, we need to simplify this if it's possible to simplify, if it can be simplified. Make sure you don't look at this and go, well, I could cancel a 2 with this 2 and this 6. You can always cancel a 2 with that 2 and 6 if you can also cancel a 2 here. Oh, you can't see what I'm doing, can you? Sorry. So all I did there was 4 plus 36 to get the square root of 40 under that radical. So y'all, when you start trying to simplify this thing, the first thing you have to do is see if you can simplify that square root. And if so, you need to simplify. We can simplify this one, I think. I mean, I don't know what the square root of 40 is, but does everybody see that if I wanted to, 40 is the same as 4 times 10, right? 4 is a perfect square, so I could say that the square root of 40 is equal to the square root of 4 times the square root of 10. And while I don't know what the square root of 10 is, I do know that the square root of 4 is 2 without the square root, right? Square root of 4 is just 2. So now that I've got that simplified, I can say that this is 2 plus or minus the square root of 40, which now we know simplifies as 2 times the square root of 10 all over 6. Only after you've simplified or checked to see if you can simplify this radical, only then do you look to see if there's anything you can cancel on top and bottom. And here's the thing that you got to make sure you know about canceling common factors on top and bottom. If this was 2 plus or minus 3 times the square root of 10, I could not cancel a 2 because I wouldn't have a 2 over here. You have to be able to cancel a factor of 2, 2 has to be a factor of every single term on top and bottom. Now, it turns out it is. This is 2. This is 2 times the square root of 10. 6, of course, is 2 times 3. So I should then cancel a factor of 2. 2 goes into 6 3 times. 2 goes into 2 1 time. 2 goes into 2 1 time. That leaves me with 1 plus or minus 1 times the square root of 10, which is just 1 plus or minus the square root of 10 all over 3. Those are my two solutions. If I can zoom out and let you see it all at once. Those are my two solutions to this original equation. Those are not nice numbers, but there are two solutions here. One minus the square root of 10 over 3 is a solution, and 1 plus the square root of 10 over 3 is a solution. In the homework, they don't care if you write it like this, where you give your two solutions separated with commas. They also don't mind if you do it like this, where you actually use that little plus or minus symbol. But if you use that, make sure that you understand that what that means is there are two solutions here, right? 1 minus square root of 10 over 3 is a solution, and 1 plus the square root of 10 all over 3 is a solution. So those are ugly numbers. They're irrational numbers, right? Your calculator could give you an estimate of what each of those numbers are, but we just leave it like this. It's the exact answer. If I wanted to, I don't know if I brought my calculator. I brought my phone, which I tell y'all not to use as a calculator, but you know, you certainly can. Let me just kind of give you a ballpark idea what those numbers are. Just so you can see that these are numbers. It's just you don't know exactly what they are. So we got 1 minus. Wonder how this one works. 10 divided by 3. So 1 minus the square root of 10 divided by 3 is about equal to negative 0.721 if I round it to 3 decimal places. And 1 plus the square root of 10 all divided by 3. Looks like that one's going to be about 1.387. And I've just rounded into 3 decimal places. But like I say, you just need to leave it like this. But the point is, we couldn't have solved this by factoring. And you can kind of see why. Remember when we solved them by factoring, you always got like whole numbers or maybe occasionally fractions for your answers. Well, these are not rational numbers, but you can still solve them. Well, let's look at one more of these. Because those numbers are irrational numbers. They're kind of ugly numbers, but they solve that equation. We're going to get even weirder answers here, I think. So let's look at this one. So x plus 6x plus 29 equals 0. Certainly can't be factored. And I will tell you all this. Sometimes it's a little tricky to look at quadratic trinomial and just know off the top of your head whether or not it could be factored. If it can be factored, that's your best approach. Factor it and look at what makes each factor 0. But for it, just to show you kind of a simple example to kind of get you thinking about it, this one would be real easy to see why it can't be factored. Because if it could be, you know you'd have to start with x and x to get x squared. You know that these last two numbers have to multiply to be positive 29, and they have to add to be positive 6. That can't happen, right? This is the only pair of positive numbers that multiply to be positive 29, and they certainly don't add to be positive 6, right? So this one is a good example just to show you an easy example to see. You know, sometimes it's a little tricky to figure out if it could be factored or not. But this one, it's certainly not hard to figure that out. It's pretty obvious. So, okay, x squared is the same as 1x squared. So our value of a is 1. B, the coefficient of the first degree x term, our value of b is 6. Our constant term, c, is 29. And now I just need to plug those into the quadratic formula. So x equals negative b, that's going to be negative 6, plus or minus the square root of b squared, that's going to be 6 squared, minus 4 times a, which is 1, times c, which is 29, and that is all over 2 times a, which is just 2 times 1. So there's what it looks like once we've just plugged everything in. And so now I just need to simplify it. So negative 6 plus or minus the square root of 6 squared is 36, right? 6 times 6. Minus 4 times 1 times 29. Well, negative 4 times 1 is negative 4. Negative 4 times 29, I think, is negative 116. I believe that's right. So under that square root, we get 36 minus 116 all over 2 times 1, which is 2. Do y'all see that we're about to get a negative number under this square root?
Yes.
And remember, anytime you take the square root of a negative number, it means you're going to have an I, right? In other words, the two solutions to this equation, there are two solutions, but they're not real numbers. They're going to be non-real complex numbers. So we got negative 6 plus or minus the square root of, is that going to be negative 80? Negative 80, square root of negative 80 all over 2. I believe that 80 is 16 times 5, right? 80 is 4 times 20, and we know the square root of 4, so we can simplify that. But we want to find the biggest square root, because if you did that, so just let me show you. If you said that 80 is the same, square root of 80 is the square root of 4 times the square root of 20, well, you could do that, and that would give you 2. Square root of 4 is 2 times the square root of 20. But 20 itself is 4 times 5. Do y'all see that? And so you've got 2 times, well, the square root of 20 is the square root of 4 times the square root of 5. And you know what the square root of 4 is? It's 2. So I've got 2 times 2, which is 4, times the square root of 5. That's the square root of 80 if you simplify it. So it's better if you just see right away that 80, that's because, see, you got 4 times 4. 16 times 5 is 80. And so the square root of 16 times the square root of 5 is the square root of 80. The square root of 16 is 4 times the square root of 5. And there's one other thing I need here. What is it?
Plus or minus?
Yeah, I need an I in there. Everybody see that? So the square root of negative 80, if I simplify it, is 4i times the square root of 5. So I have negative 6 plus or minus 4I times the square root of 5, and that is all over 2. And this is like the last problem in that every single term on top and bottom has a factor of 2, right? So I should cancel that to simplify it. 2 goes into 2 one time, 2 goes into 6 3 times, 2 goes into 4 2 times. I've got negative 3 plus or minus 2I times the square root of 5. So negative 3 plus or minus 2I times the square root of 5. And of course, that's all over 1, so it's that. So there are two solutions there, 3 plus 2I times the square root of 5 and 3 minus 2I times the square root of 5. Both non-real numbers, but both of those, each of those would give us a solution to this original equation. And I know y'all hate it when I do this. Don't feel bad, I hate it when I do this too, but I feel like sometimes I need to. I want to show y'all, we're going to do one of these two solutions. We're going to actually plug it into the original equation and check to see that it really does make the equation true. The reason I do that is mainly because I think a lot of times when we solve problems like this and we never check our work and we just say, and those are the answers. And you just look at them and go, those are like the weirdest numbers in the world. And you're telling me they're answers, but how do I know they're answers? Well, I know they're answers because if I wanted to take the time to do it, which I don't, and you should be grateful that I don't, I could actually prove to you that the quadratic formula works and that it works every single time. I can prove that. If any of you want me to prove it, let me know outside class and I'll show you how to prove that the quadratic formula works. But we're going to take that on faith. But trust me, mathematicians have proved it. I personally can prove it. I think if I look back at some of my older videos from this section, there are probably videos where I do prove it. I used to do it in class. It's just, it takes quite a bit of class time to show the proof of it. But trust me, it works. And I know I haven't made any arithmetic mistakes, so I know it works. But if you never see it working, there's always that little bit of doubt, you know. So let's try it. We'll try negative 3. I don't know. We'll try negative 3 plus 2I times the square root of 5. So that's one of the numbers that we claim is a solution. Of course, the other one's negative 3 minus 2I times the square root of 5. We'll check this value of x just to see if it really does make this equation true. So obviously, I'm going to plug negative 3 plus 2I times the square root of 5 in place of x here and here. So let me do that. So negative 3 plus 2I times the square root of 5, all squared. That's the x squared part, plus 6 times negative 3 plus 2I times the square root of 5. That's the plus 6x part, plus 29. And of course, we need to know whether that's equal to 0 to check and see if this number really is a solution. Actually, I know this looks awful, but the only part of this that's actually a little bit tedious is squaring this complex number. And we've actually looked at how to multiply complex numbers, and that's really all we're doing here. We're just going to multiply, because when you square a number, you multiply it times itself. We're going to multiply negative 3 plus 2I times the square root of 5 times itself, right? We're going to square it. Negative 3 plus 2I times the square root of 5. We're going to FOIL those. And so negative 3 times negative 3 is positive 9. Negative 3 times 2I times the square root of 5, well, negative 3 times 2 is negative 6. It's going to be minus 6I times the square root of 5. So then I'm going to move over to the positive 2I times the square root of 5 and distribute it. Well, positive 2 times negative 3 is negative 6. So I'm going to get minus 2I times the square root of 5 times negative 3. It's going to be negative 6i times the square root of 5. We do last times last. First of all, it's positive times positive. 2 times 2 is 4, so positive 4. I times I is I squared. Square root of 5 times square root of 5 is 5. Does everybody see that? Remember, the square root of 5 is whatever number you square to get 5. So if you do square root of 5 times square root of 5, you've squared the 5 square root of 5. So obviously that's 5, right? So we got 9. Those are like terms. I can combine them. Negative 6 minus 6 is negative 12. So I have 9 minus 12i times the square root of 5. Everybody remember that I squared is negative 1, right? So I got 4 times negative 1, which is negative 4, times 5, right? Which is negative 20. Okay, so all that is that part there. Then we got plus 6 times this. I'm going to go ahead and distribute that 6. 6 times negative 3 is negative 18. 6 times 2i times the square root of 5. Well, 6 times 2 is positive 12. So I'm going to get plus 12i times the square root of 5. And then don't forget we have this plus 29, the constant term at the end. And remember, we're trying to ascertain whether all that mess is equal to 0. Well, let's see. First of all, negative 12i times the square root of 5 plus 12i times the square root of 5 is 0. Those cancel, right? 9 minus 20 is negative 11. Negative 11 minus 18 is negative 29. Negative 29 plus 29, in fact, is 0. 0 is equal to 0. True statement. Therefore, negative 3 plus 2i times the square root of 5 is a solution to that equation. Everybody see? So look, I know that's tedious, and I won't do that again, but I did want you to see because when you use this quadratic formula, if it's a quadratic equation that can't be solved by factoring, it is absolutely not unusual that you get really weird looking answers. Or like in that last problem where they were irrational numbers, or this one where they were non-real numbers. That's not unusual, but they really are the correct answers, you know, if you've done the arithmetic correctly. Everybody with me? Okay, so that's our quadratic formula. Thing I would say about the quadratic formula is a lot of students, so first of all, the quadratic formula will solve any quadratic equation. It doesn't matter. If it's one that will factor, it'll solve it. Like if we had something like this. I could use the quadratic formula to solve this. I never would because I know how to factor that. And if we solve this by factoring, I mean, we know we got to start with x and x. We know these two numbers have to be positives because they multiply to be positive and also add to be positive. I just need to figure out the two numbers that multiply to be 6 and add to be 5, and y'all probably already know what those are, right? 2 and 3. And then I just have to say, okay, then negative 2 plus 2 is 0, so negative 2 is a solution. And negative 3 plus 3 is 0, so negative 3 is the other solution, and I'm done with that problem, right? But if I wanted to, I don't, but if I wanted to, I could say this is a quadratic equation. X squared is the same as 1x squared, so my A is 1, my B is 5, my C, my constant term, is 6. And if I wanted to use the quadratic formula, I could. X equal negative B, that's negative 5 plus or minus the square root of b squared, which is going to be 5 squared, minus 4 times a, which is 1, times c, which is 6, so minus 4 times 1 times 6, all over 2 times a, which is 2 times 1. And so if I simplify that, I got negative 5 plus or minus, do a couple things at once here. 5 squared is 25. Negative 4 times 1 times 6 is negative 24. And 25 minus 24 is 1, right? So what I have there is the square root of 1, which is 1, over 2 times 1, which is 2. So I left out a couple of steps there. I just did it, some of it in my head, just to speed through this a little faster. But you can see what we have. Is 2 plus 2 equal to 0? It's never going to be this number because it's what you plug in place of x that causes that to be 0. That makes sense? Yeah, that's important. I'm glad you mentioned that because a lot of times I do see students do that. They go, oh, 2 and 3 are the solutions. No, negative 2 and negative 3. It's what you replace x with to make this factor 0 and what you replace x with to make this factor 0. Everybody see that? Okay, at any rate, you get negative 5 plus or minus 1 over 2. Well, there's two answers here. There's negative 5 plus 1, negative 5 plus 1 all over 2. Of course, that's negative 4 over 2, which is negative 2. There's that solution. And there's negative 5 minus 1, negative 5 minus 1 all over 2. And that's negative 6 over 2, which is negative 3. And there's that other solution. Y'all see? So the quadratic formula solves every quadratic equation. It doesn't matter if it can be factored or if it can't be factored. The quadratic formula will give you the solutions. Now, because of that, I always have students who say, well, in that case, sometimes I'm not great factoring. Sometimes I couldn't figure out how to factor them. And sometimes, even if I was good at factoring, I couldn't factor it because it can't be factored. So I'm just going to use the quadratic formula every single time. I know students say that. Some do. But look at this problem. We solved it by factoring. Super easy to factor. Super quick and easy to find the solutions versus the quadratic formula. The biggest problem with using the quadratic formula is you've got to very carefully plug everything into it correctly. Then you've got to very carefully do all the arithmetic correctly, or you're not going to get the correct answers, right? So it's kind of like a catch-22. The quadratic formula is easy from the standpoint that you don't have to actually think about math. You just plug numbers in exactly where the formula tells you to. That's the upside. The downside is you do have to be able to do arithmetic accurately, because if you're that student that always makes little arithmetic mistakes when you start doing 5 squared minus 4 times 1 times 6 or something like that, then you're going to make arithmetic mistakes and arrive at the wrong answers anyway. So all I'm saying is y'all keep working on your factoring skills. Try to solve ones that can be factored. Try to solve them by factoring when you can, because if you can factor it, it's always quicker and easier and probably less fraught with peril than using the quadratic formula. However, if this thing can be factored, but you can't figure out how to factor it, you've tried and tried to factor it, and you just can't, it's not hitting you, and you're not finding those correct two numbers, and you can't get it factored, well, don't just give up on the problem, because if you had to, you could certainly use the quadratic formula. If you use it correctly, you'll get the correct solutions, right? Okay. So that's also in section 1.5. So that's the last part of 1.5 where we solve quadratic equations using the quadratic formula. I want to check something here. Yeah, okay. I want to make sure we were recording. I didn't start the recording, but I think somehow inadvertently Mr. Peak did when he was jacking around trying to get this to work. So we're recording. Probably means I have to cut some at the start where basically I was cussing at the screen trying to figure out why I couldn't hear anybody. But okay. Incidentally, last week's lecture recordings, I forgot to post them, so I was working on it before class started, and I've actually got both of them ready now to upload to YouTube. I'll try to do that later tonight. But the second video, where I started it recording again after the break, it was 8 hours long. Because I forgot to click leave session and stop recording at the end of the night, and it just kept recording. And what I've got is like 7 hours of the empty chairs and desks on the Paris campus on the screen. That's what it shows for like 7 hours. So I cut that out of the video. So just, all right. So let me tell y'all where we're going. We're early for break. There's 3 types of problems we're going to work on in section 1.6. Why don't we knock out the first type of problem before we go on break? It'll make the second half of class seem quick and easy and painless. So section 1.6 is titled, the title of the section is Other Types of Equations, which is the worst title for a section of a math text like in history. I mean, that could be a really long section. So far, we've learned to solve one variable linear equations, one variable rational equations, and quadratic equations. We have learned to solve 3 types of equations in this course so far. There are, I don't know, millions upon millions and billions of other types of equations. This could be a really long section. It should probably be titled A Few Other Types of Equations. We're going to look at 3 other types of equations specifically. And each one of these 3 types of equations, if you do the right thing to it, will kind of turn into an equation that we've looked at. So in other words, if you do the right thing to set the problem up, you can either treat this thing like a linear equation or a quadratic equation that we already know how to solve. So the first type of equation like that is something like this. I'm going to call equations like this square root equations. Specifically what I mean is it's an equation where you've got a variable expression of some kind under a square root, okay? And so we're going to look at how to solve these, and then we're going to look at how to solve a particular type of higher degree equation, like higher than second degree equation. We'll specifically look at 4th degree equations, and then we're going to look at how we can solve equations that involve absolute values. So we're going to look at these square root problems before we go to break. We're just going to do a couple of them. So our problem in solving this is we've got this x term that's trapped under this square root. And so really, to be able to solve this equation, we're somehow going to have to get that x out from under the square root. So here's what I'm going to do. Because I already see, because I've solved this kind of equation before, I kind of already know what I want to do in the end. And so take my word for it now, and if you don't see why immediately, you'll see why in just a minute. Before I do anything to this equation, I want to get this square root expression all by itself on one side of the equation. In other words, I want to subtract 2 on each side to get rid of this 2 that's over here with my square root. Y'all see that? So I'm going to do that. I'm going to subtract 2. Remember, it's fine to do it on one side as long as you also do it on the other side. And so when I do, I have the square root of x plus 10 by itself equals, on the other side now, I have x minus 2. So I subtracted 2 on each side just because I wanted to get that square root by itself before I started really working on the problem. So now I know that I need to get that x out from under that square root, or I need to get rid of that square root symbol, because I can't figure out what x is when all I can see here is the square root of x. So how could I get rid of that square root?
You can square it.
What if I squared it? That's very good. Yeah, that's a good thought. Do y'all agree if I square this, I'm just going to get x plus 10 without the square root symbol? Remember, I think we've talked about this a couple times already. If you square a square root, well, you've squared the square root of x plus 10, so you must get x plus 10. It's like the square and the square root kind of cancel each other out. Now, we've seen that kind of golden rule of equations. If I square the left side of this equation, what do you figure I also have to do?
Square the
Yeah.
other side.
Yeah. It's actually okay to square the left side of the equation. You can certainly see why we'd want to do it because that gets rid of that square root. But if you square one side of the equation, you have to square the other side. Be careful here. A lot of students go, oh, that's going to be x squared minus 4. Or maybe they say it's going to be x squared plus 4. It's neither. X minus 2 in parentheses squared literally means x minus 2 times x minus 2. In other words, you have to distribute or FOIL that thing with itself. And when we do, we're actually going to get x squared minus 4x plus 4. And if you don't see that, that's fine. You don't want to guesstimate. You want to be exactly right. FOIL these if you need to. But do y'all see why I knew what this was going to be without actually doing the multiplication? Because now that we've seen how factoring works, do y'all agree that now we ought to be able to look at this and go, well, that's obviously going to be x times x, which is x squared. And I see if I multiply these numbers, I'm going to get positive 4. And we know that's going to be that constant term. And we know that I'm going to get an x term in the middle and that the number in front of that x term is going to be whatever I get if I add these two numbers. And negative 2 plus negative 2 is negative 4, right? But if you need to FOIL it, FOIL it. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. Negative 2 times negative 2 is positive 4. And of course, negative 2x minus 2x is negative 4x, right? So at any rate, just make sure you see you're going to get the square root expression by itself on one side if it isn't already at the beginning of the problem. Then you're going to square both sides of that equation to get rid of the square root. Once we do this, you see that what we've actually got here is a quadratic equation. It's one of those that's got x squared. And we know with quadratic equations like this, we want to set it equal to 0. So I'm going to move everything to the side of the equation that's got x squared on it. So I'm going to subtract x on each side. I'm also going to subtract 10 on each side. I'm just going to go ahead and do both things because I know I'm going to do both things. And when we do that, notice what I'm going to get on this x squared side is x squared negative 4x minus x, that's negative 4x minus 1x, that's minus 5x. And 4 minus 10 is what, negative 6? So minus 6 equals, of course, 0. And this is a quadratic equation that's set equal to 0. If I had to use the quadratic formula on this, I certainly could, but I don't think I need to because I think this can be factored. What are the numbers that I need there?
3 and 2.
1 and 6, which one of those is going to be positive and one's negative, right? Which is which? I agree the numbers are 1 and 6, but they have to have opposite signs because they multiply to be negative 6. Which one of these should get the negative sign?
The 1.
What's the sign we're supposed to keep when we add them? The negative sign? Don't you always keep the sign of the bigger number when you add numbers with opposite signs? Wouldn't the negative number need to be the bigger number? Wouldn't it be plus 1 and minus 6? Why? Because 1 minus 6 is negative 5. If I did it the other way, negative 1 plus 6 is positive 5, but we don't have positive 5. We need negative 5. Everybody see what I'm saying there? Those signs matter. You got to really check the signs and make sure that it works. Positive 1 times negative 6 is negative 6. Check. 1 plus negative 6 is negative 5. Check. That's factored correctly. Okay, then what are my two solutions? Negative 1, positive 6, right? Now, let me go back and look at my original equation. Let me write it again because I can't get everything on the screen at one time. That was my original equation. Here are my solutions, -1 and +6. Y'all take a minute and plug -1 into this equation in place of x and see if you get a true statement. In other words, check our solution for -1. Check it to see if it really is a solution to this equation. It should only take a few seconds. Is it a solution? Crickets chirping. All right, everybody look up at the board then. I'm going to plug -1 in place of x in both of these places. Is -1 plus 10 equal to 9? Yes. Is the square root of 9 equal to 3? Yes. So when I plug -1 in on the left-hand side, I get 3 plus 2, which is 5, right? But then I also have to plug -1 here in place of x, and I get 5 equals -1. Is that true? Of course not. Of course it's not true. I'm just saying, y'all are taking too long. You gotta, like, plugging -1 in here should not take you 5 minutes to figure out if this is a true statement or not. Y'all gotta think about what we're doing. -1 doesn't work. That's the big point here. The other one, if I plug 6 in place of x, I get square root of 6 plus 10, and then plus 2 equals, well, I got to plug 6 in here too, equals 6. 6 plus 10 is 16, and the square root of 16 is 4. 4 plus 2 is 6, so I get 6 equals 6. That's a true statement. So 6 worked, but -1 did not work. So the moral of the story is here, we did not do anything wrong when we solved this equation, but the method that we had to use to solve the equation has introduced, it's introduced what I'm going to call an extraneous solution. You know, when you square a number, like for instance, do you agree that that statement is false, right? -2 equal 2 is a false statement. But what if I square both sides of that equation? If I square both sides of that equation, I'll get a true statement, right? Doesn't change the fact that the original statement was false, though. And so that's kind of what happens. And if we had looked at this equation, I'll tell you what, maybe we'll do it on this next one. Well, if we had looked at this equation at this stage where it was square root of x plus 10 equals x minus 2, remember that's what we got once we subtracted 2 on each side. Of course, I went back to the absolute original equation to check it. That's what we should always do. But just to show you, you can see what happened. If I were to plug that, what was it, -1? If I were to plug that -1 in here, you'll see exactly what happens. When I plug -1 in here, I get the square root of -1 plus 10 is 9. Equals, here I plug -1 in, I'd have -1 minus 2. Well, there is, and -1 minus 2 is -3. But the square root of 9 isn't -3. The negative square root of 9 is -3, but we don't have a negative in front of it. The square root of that thing is just +3. That's a false statement, right? And so you can see how if I squared both sides of this, which I did, then it's taking that false statement and making it true for that one value of x, -1. You can see that if I plug 6 into this, I'd get the square root of 16, which is 4, equals 6 minus 2, which is 4. One of them works, the other one doesn't, right? So that's the one thing you got to watch out for when you solve these square root equations is once you solve it, you've got to check each solution in the original equation to make sure it really works. Because even if you do everything right, sometimes you'll introduce what's called an extraneous solution, something that looks like a solution but isn't. Basically, when you solve this thing and you get to those, what are a lot of times going to be two different solutions, you should think of it like, if this equation has solutions, those are the only numbers that might be solutions. Then you check them to see if they both are, or if only one of them is, or whatever. Okay, so this one, it's already set up where we got the square root by itself, so I need to square both sides. And of course, on the left side, I just get rid of the square root symbol. I just get 2x plus 13. On the right side, I have to do x plus 7 times x plus 7. We all ought to be able to FOIL that with itself by now, but make sure you see, like a lot of students here, they're just going to write equals x squared plus 49 because they're just going to do x squared plus 7 squared, but you can't do that. You're missing the outside and inside parts of FOIL if you do. So x plus 7 squared means x plus 7 times x plus 7, and that's going to be x squared plus 14x plus 49. And y'all ought to be able to, if you need to, FOIL that with itself to see that that's correct. So now we've got to set it equal to 0. You know, the problem pretty much proceeds just like the last one. I'm going to move everything to the x squared side. So subtract 2x on each side. And I'm also going to subtract 13 on each side. So when I do on this x squared side, I'm going to have x squared. 14x minus 2x is positive 12x, so plus 12x. And 49 minus 13 is what, positive 36. And of course, that's equal to 0 because everything on the other side cancels. Now this problem, so first of all, does everybody see how we got there, how we set it up? This problem is a little bit interesting. I don't think we've actually seen an example of where this happened yet. But so it's good that we ran into it. When you factor this, what do y'all think my two numbers need to be there? Positive 6 and positive 6? Yeah, you're right. Do y'all see that? See, look, positive 6 times positive 6 is positive 36, the last number. 6 plus 6 is positive 12, the middle number. So that's factored correctly. So what are the two solutions to this equation?
6 and
Negative 6 and negative 6, right? There's really only one solution there. Do y'all see that? Now we still got to check and see if it solves the original equation, but I just want to point out this is a second degree equation. And remember, we talked about the fact that, well, when we solved those linear equations where we just had x to the first power, it seemed like we were always getting exactly one solution. And we've been solving these second degree equations where you have an x to the second power, and we've always been getting two solutions, right? Well, here's a second degree equation we solved, but we only get one solution. Everybody see? This is actually kind of a little bit of an important thing. In fact, it's important enough that what I'm about to say is called not one of the, or not a, but the fundamental theorem of algebra. And in the simplest terms I can say it, the fundamental theorem of algebra says if you have an equation a polynomial equation where you just got, these x terms or constant terms like this, then the equation will always have exactly the same number of solutions as the degree of the equation. In other words, a first degree equation will have one solution. A second degree equation will have two solutions. A fifth degree equation will have exactly 5 solutions. But there is a caveat. There's a little disclaimer there. It says that any polynomial equation will have the exact same number of solutions as the degree of the equation, but they're not necessarily all distinct. In other words, for that rule to be true, we have to agree that if we get something like this, -6, we only have one solution, but notice the factor that causes it to be a solution got repeated 2 times. Y'all see that? So it's sort of like we have 2 solutions. They happen to be -6 and -6, right? It's so as long as we're willing to count solutions that get repeated each time they get repeated, then we always say that like a 7th degree equation will have exactly 7 solutions. At any rate, what this tells us is there's only one possible solution to this equation. We still need to check it. So we go back up to the original equation, square root of 2x plus 13 equals x plus 7. We just want to plug -6 in and make sure we get a true statement. I think we will this time, right? Because if I plug -6 in here, 2 times -6 is -12. -12 plus 13 is 1. The square root of 1 is 1. And on the other side, when I plug -6 in, -6 plus 7 is also 1. That's a true statement. Then -6 is the solution to that equation. Everybody see? So with these square root equations, you usually will get 2 possible solutions. And when that happens, I'm not going to say always or never, but I'm going to say usually. I'm going to say if you get 2 different solutions, your expectation is that one of them is probably going to work, one of them is probably not going to work, and you need to know which is which. If you just get one solution, I'm going to say probably it's going to work. But you still need to check it to make sure it works. So anyway, does everybody see how to do these? If you have something like that with a square root, just get the square root expression by itself. You square both sides of the equation. Once you do, it turns it into a 2nd degree equation, which we've already covered, right? We literally just covered those. And so you solve that, then it's just a matter of checking each thing you get as a solution to make sure it's really a solution to that original square root equation. Everybody with me? Okay, so 2 more problem types we're going to look at from 1.6. Let's take our break. It looks like it's about 7:05. Oh no, 7:15 to 7:17, somewhere in there, 10 or 12 minutes. We'll get rolling again. And I'm going to stop recording.